Now in this video we'll be talking about the hydrologic cycle or the water cycle, and this is a very important cycle because all life on Earth depends on the cycling of water in the hydrologic cycle in the Earth system. You can see the reservoirs of water in the Earth system in the table in the right, where there are many reservoirs of water. There's the atmosphere, fresh water in lakes and rivers. There's also the fresh water in the underground, the alpine glaciers, the Greenland ice sheet, the Antarctic ice sheet, oceans, and the crust and mantle. The second column is the amount of mass for each reservoir, but per area, specifically per meter square, and the amount is in the order of 10 to the power of 3. So we see that the atmosphere has the smallest amount of water, while the crust and mantle has the largest amount of water. The residence time of each of these reservoirs are vastly different, where the residence time of the atmosphere is in days, while the water in the crust and mantle goes up to 10 to the power of 11 years. This means that the atmosphere has the smallest amount of water and also has the largest rate of exchange of water between the different reservoirs, which also means that water easily moves between atmosphere and the other reservoirs because of the large exchange rate. Which also means that the atmosphere has the most effective branch of the water cycle. Now, how does water exchange between the atmosphere and the other reservoirs? Is through precipitation and evaporation, where precipitation means water is removed from the atmosphere, while evaporation means water is added to the atmosphere. Looking at precipitation and evaporation globally, we see that the amount of precipitation and evaporation should be the same, where there's a zero accumulation of water in each reservoir. But if we look at the small scale, we see that this balance also depends on the horizontal transport of water, or the water that is carried by the wind, such as in the ITCZ, or the intertropical convergence zones, where there's a lot of rain. Then we see that precipitation is much higher than evaporation. But in the dry zone or in the subtropical areas, then we see evaporation will be higher than precipitation. In general, over continents or over land, we see that precipitation will be more than evaporation, but the precipitation that comes onto the land would runs off to the ocean by rivers. So under steady state conditions, we see that evaporation, when we minus with precipitation, should equal to the amount of horizontal transport of water. This is the mass balance of the storage of water per time, which is denoted as this equation, where dST is over dt equals to the average precipitation minus the evaporation minus the horizontal transport. Now we introduce a new term in the equation, which is ST, which stands for storage. We see that the change of storage with time is dependent on the amount of precipitation minus the evaporation and also minus the horizontal transport. But if we look at a lake or a basin of water that does not have an inflow or outflow of surface water, then the horizontal transport would be 0, which simplifies the equation to become dST over dt equals to precipitation minus evaporation, which implies that the storage of water in this lake or in the basin would be only dependent on the changing precipitation and evaporation.